welcome to the video of the power series expansion. And now we have the example problem number 3. And here is given y double prime is equals to y. And we have, of course, a generic form of y is equals to summation of terms when n is equals to 0, c sub n x raised to n. And deriving that, we will have y prime equals summation of terms when n is initially 1. Then deriving this part, we will have n c sub n x raised to n. Deriving that, also we will have y double prime is equal to summation of the terms when n is initially 0, initially 2. And deriving this part, we will have n multiply n minus 1 c sub n x raised to n minus 2. And in the problem, we have y double prime and y, so we can substitute this form. We could also transpose y to the other side, so we will have y double prime minus y is equal to 0. So we will substitute the generic form of the power series, minus 2 minus y c sub n x raised to n is equals to 0. And now we will notice that we don't have a balanced summation sign. So we could balance this by simply subtracting 2 here, so we will result in n is equals to 0, and by doing that, so we will also add 2 in this whole equation. So we will do that. We will have then summation of terms 2 minus 2 is equals to 0. Then we will have n plus 2 here, n plus 1, c sub n plus 2 x raised to n minus summation sign n is equals to 0, c sub n x raised to n is equals to 0. And now we could factor out the terms, the summation sign, and the x raised to n sign. So factoring that out, we will have this term, c sub n plus 2 minus c sub n x raised to n is equals to 0. Now we will have the equation where x raised to n is not equal to 0. We will have this part. I'll bring it down here. And we can now perform the recursion relation. We should solve for the highest index, so c sub n plus 2. Transpose this c sub n to the other side, and we'll divide n plus 2 n plus 1. So that is now the recurrence relation of the differential function. So now that we have the recurrence relation of the differential equation, we can now substitute the n terms, so we will have the coefficients for the series. So we will do that. I will rewrite this up. So we have c sub n plus 2 equals to c sub n plus 1 multiply n plus 2. So at n is equals to 0, we will have c2 is equals to c sub 0 over 1 multiply 2. At n is equals to 1, we have c sub 3 and c sub 1, 2 multiply 3. At n is equals to 2, we have c sub 4 and c sub 2 over 4 and 3. At n is equals to 3, we have c sub 5 is equals to c sub 3 over 5 multiply 4. At n is equals to 4, we have C6 over C sub 4, 6 multiply 5, and at n is equals to 5, we will have C sub 7 is equals to C sub 5 over 7 times 6. So we can actually simplify all of these terms by, if C sub 2 in here, we also have C sub 2 in here. So we could multiply this whole equation to this one. So we will have then C sub 0 over 4 factorial. And we could also do that to the whole equation. So now we will have, by simplification, we can now substitute all of those n coefficient to the generic form power series equals to 0 series xn, where c sub 0 plus c sub 1x plus c sub 2x squared plus c sub 3x cubed, and goes on and on. So now, for the even coefficients, we have c sub 2n. So for even, we will start with 2. So this will be even number. And c sub 0 over 2n factorial. And for odd coefficients, we will have then c 2n plus 1 is equals to c sub 1 over 2n plus 1 factorial. So that will be true to all of the terms in this series. So substituting that, we will have y the function of x c sub 0 1 plus x squared over 2 factorial x raised to 4 over 4 factorial, and so on. That's for the c sub 0 coefficient. So now that goes for the c sub 0 coefficients. Now we will have to simplify all of the c plus 1. So I'm going to rewrite this part. So now we have y of x, c sub 0 1 plus x squared over 2 factorial plus x raised to 4 factorial plus c sub 1. We have x plus x cubed over 3 factorial plus x raised to 5 factorial, goes on. So now we could notice that this part is actually a series expansion of the term hyperbolic cosine of x, and this part is also a series expansion for the sine hyperbolic of x. So with the c sub 0 and c sub 1 here, we could simplify them as c sub 0 multiply cosine hyperbolic plus c sub 1 hyperbolic sine. So this is the transcendental function. The answer for the power series expansion of y double prime is equals to y.